All right, welcome everyone. This is the first workshop between McGill BioDesign and McGill aCADemy. And in this one, we're essentially going to be teaching the basics of CAD. So everything pertaining to creating reference geometry, sketching, and so on and so forth. So I'm part of McGill aCADemy. So we're a primarily mechanical engineering based club, but we're trying to branch out a little bit, and I'm here to lead the tutorial. So I'm going to share my screen and we're going to get going. All right. So essentially I have SolidWorks open right here, and you'll notice there's a few different features that you can click on. So the primary three are parts, assemblies, and drawings. So we'll get into each of those respectively. Parts, as the name sort of insinuates, are singular sort of components of assemblies. So essentially think of it as like a Lego structure. The whole Lego structure all together is an assembly, but a part of it is like a block. So that's primarily what we're going to be focused on today. But then once we have multiple parts, we can create a new assembly file. And from there, we can mate them together and create new designs from that. So if you click on advanced as well, you'll notice it gives you options in here. It also gives you tutorials as well. But for the most part, we should be fine. So I'm going to click on part here as our new SolidWorks document. And let me know if any of you who are following along, if you're getting lost or if you need any advice, I'll let you know what to do. So yeah, one moment. My computer's being a little bit slow here. My apologies. Okay. It is a pretty big software. It takes up quite a lot of RAM. So definitely if you have a less intense computer, I would not recommend using it on your computer directly. Rather, remote desktop's the way to go. Okay, sweet. So now we're loaded in, and you can see there's quite a lot of features to deal with. It can be pretty daunting at first. So I'll go through everything one by one. So right here in front of us is our sketching and modeling plane, or sort of our frame of reference. And right here, if you guys can see my cursor, is our coordinate system. So essentially we have our Z, Y, and X planes, and those essentially help with orientation. As well, you'll notice we have these planes. So if I right click and press show for each of them, you'll notice we have three different initial planes from which we can create models on. And I'll show you how to do that. In addition, though, you can actually create new planes for yourself. So this is going to be an essential tool to learn. But essentially, if you see this tab here, reference geometry, you can put in a plane, an axis, a new coordinate system, or a point. For the most part, you're going to be sticking with planes. But I mean, if you're doing anything with circular or cylindrical objects, axes are definitely going to be beneficial in that regard for creating revolutions. But let's create a new reference plane. So say we create a new reference plane, and essentially, this tool takes a little while to load. We're going to want it to be approximately 5 millimeters away from our top plane here. So I'm going to click this as our first reference. And as you can see, it gives me the choice for what type of relationship we want with this plane. So we can have it be parallel to our top plane. We can have this new plane be perpendicular. So if I do this, you'll notice we'll actually need another constraint because it's free to move along the Z axis. So if I set, for instance, the right plane as our second reference, oh, that's not valid. So we choose another constraint. But that's not what we want. We want to go with the distance constraint. And coincident essentially means that they're going to touch. So that's usually what you choose if you want to create a plane on a surface. But say we want this to be approximately 50 millimeters away. We can do that. And you'll notice it augments the distance from the top plane to our current plane accordingly. In addition, what we can do is we can create multiple planes. So say if we want to make, I don't know, 4 plane. So we can do that, and you'll notice it actually created quite a few. And I'm going to hide these 3 planes that we had before by shift clicking all of them and right clicking on the hide button. And I'm just going to remove 3 of them. So we'll delete these 3. As well, it doesn't really matter for the purpose of this tutorial, but I'm going to change my unit system. So as you can see here, we're currently in MMGS units. So as it says, if you hover over, we're in millimeters, grams, seconds. Now, depending on the type of project you're working on, you're going to want to cycle through these. But for the purpose of this, we'll stick with CGS units. So centimeters, grams, seconds. All right. Now I'm going to get rid of this plane as well. And I think we can get started with sketching. Any questions so far? Okay, I don't see anything in the chat. So I'm just going to get started with this. So right beside the Features tab, which is essentially all of the tools you require for 3D modeling, you have the Sketches tab. Oh, we have something in the chat. It says, I can't make my planes stay on the screen. Okay, could that be your distance? So if you set an extremely high distance, there's a chance you're going to be past your reference frame. And in the meantime, we'll create a new sketch. So a sketch is essentially the 2D basis for whatever 3D model you make. So essentially, if I press sketch here, it gives you 3 different planes that are default planes to choose from. So these are sort of reference geometry that we can base our model upon, if that makes sense. And it'll make more sense as we go further into the steps. So if I go into our top plane here, oh, and we have something in the chat. Yeah, exactly. Thank you, Nathan. So what I've done is I've created a new sketch upon our top plane. So as you can see here, if I rotate, so you can rotate your screen using the middle mouse button and holding that down. And you can zoom in and out with your mouse as well. So scroll in, scroll out, so on and so forth. And if you want to recenter your screen, just press F. But essentially, what I'm going to do is I'm going to make sure that our point of view is perpendicular to our plane. So I'm going to press this Y-axis button, which is the axis that is perpendicular to this top plane. And essentially, you have all of these different sketching tools here. So all of this is in 2D, right? And upon this, this reference frame, what we can do is say, you know, create a rectangle. So let's do that. Just a basic rectangle. And there, sorry, I can't speak. You'll notice there's multiple types that you can select as well. So currently the default is, you know, going from one corner to the opposite corner. It really depends on what you want to do, but I'd advise if you want to get more familiar with these guys to practice with them quite a bit. But you'll notice we have multiple different features available at Bang. So for instance, we have existing relations. These are going to be extremely important. And essentially, relations are constraints. Think of it like that. So your sketch, initially, when you create it, it's unconstrained. And as a result of that, when you create, you know, some sort of change within your sketch, nothing will update accordingly. And everything's essentially free to move. So that's not good. In most mechanical design projects, you want your sketches and your models to be fully constrained, such that if, you know, some other person on your team changes something, your whole model updates accordingly, and it sort of adapts to the new change. So we can do that with multiple tools, which we'll see further ahead. But essentially, if I press escape, so I've deselected this rectangle, you'll notice that these sides are blue. And essentially, when they're blue like this, it indicates that it's underdefined, as mentioned here below. So right there. And essentially, underdefined also means under constraint. So the way to do this, or the way to address this, is one, putting in dimensions. So dimensions allow you to dictate how long you want something to be, or, you know, it allows you to dictate angles or anything like that. So say we want this to be 10 centimeters long. We can do that. Say if you want the angle between this side length and this side length to be, let's say, 30 degrees. We can do that as well. But you'll notice since it's a rectangle, we can't do that quite yet. And that's because of the innate relationships that the rectangle has. So you're going to want to change that up for different geometry. But I just wanted to show you that for the sake of knowing what you can do with the dimensioning tool. But let's say this one's going to be 10 centimeters as well. And you'll notice it's still underdefined, even though we have, proper defined side lengths. And the reason for that is because this rectangle within this plane is completely free to move. And as a result, if it's completely free to move like that, whatever change you provoke in something else won't affect this. It's sort of doing its own thing. So the way to prevent that is to actually constrain it with respect to your little origin here. So these two red arrows, that represents your sketch origin. So what I'm going to do is I'm going to create a smart dimension. And I'm essentially going to say this side length is going to be, let's say, 5 centimeters away from the sketch origin. And you'll notice that these two sides are now fully defined because they have length and they also have a position with respect to our coordinate. Furthermore, if we take this guy and constrain it with respect to our coordinate again and say 5 centimeters, our sketch is fully defined. And you'll notice it says that right here. Now, say if I got rid of one of these dimensions and I pressed exit sketch, you'll notice right beside the sketch that we created, there's this sort of minus sign here within the property tree. And that indicates that your sketch is underdefined. So whenever you're working through a project and you see a sketch that has that, you're going to want to get rid of that. Unless if you're, intentionally leaving it underdefined, which is possible as well. So for the purpose of this, I'm going to get rid of that. Now that's one way of constraining your sketch. But the other way is to use relations. So that was dimensions. And you'll notice you have these different types of dimensions as well. But for the purpose of our tutorial, we're not going to get into a lot of these. Mostly the smart dimension tool is going to be your best friend. But say if we wanted to constrain with relations, well, this is what we do. Say if we select this midpoint, which will automatically pop up when you scroll your mouse over it. And say if we shift click on our sketch origin right here, we have two selected entities here. So point 1 is going to be this point that we have here, and point 1 at origin is going to be our sketch origin. And these are the relations we have at hand. So one would be horizontal with respect to your sketch origin. So this is your horizontal axis for your sketch origin. So if we press that, it's fixed from a horizontal standpoint. So say if we wanted to move this up and down, you'll notice we actually can't. So if I hold my left click on it, we can't move it up and down, which is a good thing. As well, say if I went and clicked on the midpoint of this guy as well, and I shift clicked on the sketch origin once more and pressed vertical, you'll notice it's fully constrained once more. So if I go back into here and try to move anything around, you'll notice it's impossible. We can't. So this is also another example of a good sketch. Now let's play around with some other shapes. So say we want to work with circles. Now there's multiple ways of deleting this rectangle here, or this square, I should say. So I'm going to click on all side lengths here, which is just clicking the cavity in the middle. And you'll notice if I press delete, we can delete it in one respect. And this message that's popping up is essentially saying, okay, we have relationships between this rectangle or this square and the sketch origin. And essentially, if you delete the the square, those associations are going to sort of disappear. They're going to be deleted. So we want to say yes to all because we have no need for our rectangle. So Normally, you don't want to do this if you have something that's dependent on something else and you're going to be lost if you delete that. But for the purpose of this, it should be fine. So I'm going to create a circle. So say if I create a circle, so you click on the sketch origin and then expand. That's one way of doing it. Another way of doing it such that it's constrained would be to expand it like so. Then click on its origin, click on the sketch origin, and press coincident. So this relationship dictates that they're going to be in the same spot. And let's see, we have something in the chat. So how do you get the sketch origin? So that's going to be something that's automatically loaded in once you create a sketch. So say if I exit this sketch, right, and I create a new one, and we go into our feature tree to select a plane. So let's do another plane. Let's go with the right plane, right? You'll notice it's automatically loaded into our sketch plane. So it's automatically loaded into our reference geometry. So does that help, Charlotte? Yeah, okay, perfect. So I'm gonna go back to editing this sketch by right-clicking on the sketch and pressing Edit Sketch. And you'll notice it's underdefined as well, as per usual. So what I'm gonna do is I'm gonna add a dimension to it. And you'll notice this circle with one dimension is fully defined. And you may ask, why is that the case? Why did we have to constrain multiple things with the rectangle in the previous dimension? And that's precisely because of the fact that we've limited two separate things here. So this is sort of a general rule for CAD, but essentially whenever you're creating a sketch, if you want a sketch to be fully defined, it should not be able to move at all, right? And the other way is it needs to have its length defined in some way, or its physical properties defined in some way. So say if I got rid of this dimension here, it's fully constrained within the sketch origin because we put that coincident relation between this point and the sketch origin. So the circle's point and the sketch origin. But if I click on the outer edge of this circle here and expand, the radius is still mutable, or it's changeable. So this is not something we want. So essentially I'm going to put a dimension to constrain that. And there we go. Now, say if we want to get rid of the circle, say if we want to do a half circle of some sort, right? What we can do is essentially insert a line from its extrema, so its outer edges. And you'll notice it automatically aligns the line with respect to the axis we're working on. And this line is fully defined because I selected distinct points that the circle provided once I scrolled upon it. But you can create new relations to constrain your own points, and I'll show those as well. Now, if I do this, and if I press the Trim Entities tool, sorry about that, what we can do is it automatically selects the Power Trim model, or the Power Trim tool. And if I hold down the left click and drag down, you'll notice it automatically gets rid of any lines that are not formed. So any lines that form a curve outside of what we've selected. So we can do this with multiple things. Say if I create like a new rectangle as well, and we're going to put another rectangle within that. Oh, my apologies. For some reason that selected earlier than I wanted it to. We'll create a new one within it. And we want to get rid of all the lines on the interior. With the Trim Entities tool, it actually makes our lives a lot easier because essentially what we can do is get rid of this line here. We can get rid of these two lines here. And essentially we have this cavity that's completely free. So rather than deleting lines and creating new lines, this is a far more convenient tool to use, and I definitely recommend it. As well, it's not the only thing that you can use. If you go into Trim Entities and press this down arrow here, you'll notice there's a feature called, or a tool called Extend Entities. And if you click this, you'll notice on any line that you've created previously, it automatically infers completing the distance from that point. So from the furthest point that your existing line exists upon, and going to the next thing that it intersects with. So if I do this, so if I just click on that line, it automatically creates a line that's fully defined from where we started to where we want it to go. It's sort of like the until next feature, which we'll see quite soon. So I'm going to get rid of this rectangular sort of contraption that we created here. And I'm going to add a little bit to our circle here. Let's say we create a point that is on the same axis as this origin here, and we can ensure that by clicking on the origin, shift clicking on our point, and putting a horizontal relationship here. And you'll see when it is bold like that, it automatically sort of infers. It's sort of guessing what you want to do. And usually it does help out in that regard. And say we want to essentially extend 2 lines from where we're at. So what we have is this line. We'll say it just extends like so. We don't really need to put a lot of care into it quite yet. And essentially what we want to do is we want to connect these lines to our circular structure, and we want them to be tangent. So what you can do is you can click on one of these lines, shift click on the circle, and you'll notice there's also a tangent relation as well. And if you click on that, it automatically infers the best spot to go such that your line is actually tangent. It doesn't intersect, it just touches your circle. And furthermore, you can use the trim entities tool and get rid of all the excess. So rather than measuring everything and ensuring it lines up, you can just use relations and trim entities to your advantage to sort of facilitate the whole process. So essentially, we want to do the same with this line as well. We want it to be tangent, and we want to get rid of the excess. And you'll notice it's not fully defined because this is still free to move along the x-axis. So this point, we can still change it. So to ensure that it's defined, what we need to do is actually set a dimension for it. So a dimension with respect to our origin. So if we press like 20, for instance, there we go. This is what we have. And another thing to point out here is the fact that what we have is one solid entity and one transparent entity. And essentially what that is it's SolidWorks inferring what is a closed contour and what is not. So if we get rid of this line that's separating these two, essentially you'll notice that now we have one uniform color, which is what we want. As well, what we can do is we can actually mirror this. So if I mirror these different lines, and we're going to mirror it about, and we're going to get rid of this last line. So I'm going to right click on this last line, and we're going to mirror it about the line that we just deselected. If we do that, you'll notice we actually have unique structures like this. And furthermore, if you want to actually extrude it, and this is something I'm going to touch on, you can get rid of this line here. Now, the reason why we had to do that was because of the fact that if you have lines like this, imagine sort of extruding it towards you. So if I rotate this sketch, imagine going upwards like this. You're going to have a gap in between 2 different sides, which for the purpose of most of the objects you want to create is not good. So we'll address that quite soon. So I'm going to get rid of that. And essentially, you'll notice that this side is not constrained anymore because that was a reference feature. So let's undo that. And essentially what we can do is replace that. So I'm going to right click on this guy. And let's see. So there's this feature called construction geometry. And essentially what this line is right now is it's a physical being. So essentially SolidWorks will see this and consider it to be part of the sketch that you're trying to create. But if you convert it to a construction geometry or a piece of construction geometry, essentially it's invisible, if that makes sense. So this is a useful thing to do, but for the purpose of this, I'm just going to get rid of it. Sorry for the confusion there. And I'm going to constrain this. So shift click there, press horizontal, and then we're going to apply a dimension. So let's say 20 centimeters. Nice. Oh, we have something in the chat. Sorry, how did you delete the half circle? Sure, I'll go back. So if I delete everything, there we go. So we were at this point, Alice. And essentially what I did is I pressed the trim entities tool. So the trim entities tool will allow you to sort of delete any contours that are being closed off. So essentially you see there's an intersection here, there's an intersection here. So SolidWorks automatically infers that if you drag your mouse through here, it wants to get rid of that little arc that we had. So does that make sense? Yeah, no worries, no worries. All right, so I'm just gonna go back and mirror this. So we'll take all of these different lines and mirror them about our central axis. And we're essentially gonna trim this central axis out of here, right? And we can just set different constraints here. I'm just gonna quickly constrain everything with a couple of dimensions. So we do that, and then we ensure that this whole thing is horizontal. And I'm just doing this quickly. For the purpose of this tutorial, it doesn't really matter too much, but now we should be fully constrained. We're still underdefined. It's likely a point, but we're gonna ignore that for now. So this is ready for extrusion. Now, one last thing that I wanted to show was the linear sketch pattern feature, which is also pretty cool. Essentially what you can do is select a contour like this and create duplicates of it. So say if we want it to be 5 centimeters away from the origin of our sketch, let's do a larger distance, let's say 20. And we create, so this is along the x-axis, which we selected down here. Let's say we want to create like 4 instances of this. You'll notice if I press OK, we have this sort of patterned feature and it's duplicated. If I go back into that, so linear sketch pattern, we can change the axis that we're selecting. So for instance, I want to go, so I'm going to delete that. Let's create a new axis for ourselves. So let's say we have a line that goes up here. Let's go in the y axis or the z axis with respect to our sketch. So I'm going to click this contour. So entities to pattern. Let's click that. And for our direction, we're going to click this. And then we're going to go by 10 centimeters. Oh, for some reason, it has automatically. Yeah, not sure why it did that. But essentially, what the point I wanted to get across was the fact that we can essentially translate this both in the Y, X, or any axis that we create. So we can even create like a diagonal line that goes all the way down here and have our shape move down with respect to that. An easier way to do it would be to use reference geometry. So using the axis feature that I mentioned before. But since we don't want to do that, I'm not going to go through with that. In addition to that, we also have the circular sketch pattern. So that's particularly useful if you want to rotate, as we see here, and create multiple instances in that respect. So say if we want to create like 6 different or 8 different stars like so. If we press OK like so, what it did is it chose an axis. So presumably, if you can imagine, you see this Y axis here. It likely rotated about that axis and created 8 different instances of our previous shape. So again, that's a really, really important feature that we'll actually be using quite a bit for the design of our mask in our upcoming tutorials. But for the sake of this, I'm going to go to the next step. So I am going to extrude this. So now we're actually getting into 3D modeling. Now, if I go and press Extruded Boss /base, you'll notice what it does. So just give it a moment. There we go. It gives us the option to extrude our object. And this is the basis of everything you're going to be doing with SolidWorks. Everything is essentially an extrusion of some sort or a revolution. So this is one way of doing it. It's very basic. This is the blind feature. So essentially you specify a distance in which you want to expand this. So if I press OK, we went from a 2D sketch to a 3D object that has a height of 10 centimeters. So my document is actually in US imperial units or US customary units. So that's why it's showing it as inches, but that's something you can set. But this is 10 centimeters. If I right click this, you'll notice you can both edit your feature, but you can also edit the sketch. So if there's something you find that's not satisfactory in that regard, you can edit that and it'll automatically update. For instance, if I do what I mentioned before with the intersecting vertical line, so we bring that guy all the way down and press exit, you'll notice it's actually going to cause some errors. So if we exit the sketch and rebuild, it created an open contour. And if I edit the feature and go back, we have to select new contours. So we select one side, we select the other, and now it creates what we wanted to create. But if you want to create one homogeneous body, I would not recommend putting a line like that. You don't want any self-intersecting geometry. So that's one way of extruding. As well, we have a couple of other features as well. So we can choose where we extrude from. So say this is not satisfactory. Say if we want there to be an offset, we can establish that. We can say, okay, we want this to be 10 centimeters away from our sketch plane. And this is particularly useful if you don't want to create a new sketch. You just want to reuse a sketch, but you sort of have something in between where you want to extrude and where you want to start your extrusion. So that's one other way of doing it. You can also choose a surface from which to do this from. So if you have multiple different extrusions, that's one way to go at it. And I'll show this quite soon as well. And you can also go from a vertex too. As for the types of extrusions, you can do it up to a surface. So similar to the extend tool that I showed, if you have another surface that's on the same axis, so it's going to intersect if you extrude this by a certain amount, the extrusion will actually go up to that surface. So say if I quickly go back and within our sketch, I'm just going to create an offset sketch. So I'm just going to press offset entities, select this contour. Going to give it a moment. Oh, there we go. That took a little while. Press make it offset by 2 centimeters. And this is sort of a more minor tool. We sort of skip over it for the most part. And we press exit. Of course, this is going to give us one extrusion. And what I'm going to do is I'm going to make this visible. So I right-clicked and pressed show. And it's still underdefined, but that's fine for the purpose of this tutorial. And I'm going to create a new extrusion. So I'm going to click on this contour. I'm going to clear our selections. And essentially, you'll see we have two different options to choose from. Since these are two different closed curves that are encapsulated by one another, we can choose the one on the outer edge or the one on the inner edge or both. It'll create one solid object. So let's do both, for instance. Let's see how that looks. Well, now you'll notice what we're doing is essentially just overwriting our previous extrusion. We don't want this. We want them to be two distinct bodies. So we press from, go from a surface, and we click our new surface. So there we go. And now what we have is a 10 centimeter extrusion that's from this face. And if I press OK, we have two overlapping bodies like so. So, I mean, that's pretty cool. Another way of doing it would be to actually create a new sketch. So if I create a new sketch on here, the most logical thing to do would be, to trace it out. But honestly, that takes a lot of time, and I want to skip some steps. So now I want to introduce the Convert Entities tool. This is also very useful. Say if you have like a type of sketch geometry that you need to reference, and you don't want to recreate it once more, the Convert Entities tool will essentially take the sketch geometry or even a face, any type of sort of physical contour that the program can analyze. So for instance, if I press this face, what it's going to do is it's essentially going to take the edges of the face and project it onto our new sketch, if that makes sense. So if I press OK and hide this object, you'll notice essentially what we did is we copied everything from the face from where we created our sketch upon, and we essentially projected it onto our new sketch plane. So that's really useful. As well, we can do it for existing sketches. So say these contours here, I'm going to select a chain. So essentially it automatically selects everything for us. And if I press OK, you'll notice it automatically created that offset for us, and we did not have to do any work, and it's fully defined too. So I mean, that's also pretty nice. Now, that's one way of doing it. The one thing I'll mention though is it is a projection. So similar to how you have, say if you have like some sort of object, like I have this notebook, it's essentially taking the shadow of it and projecting it onto your sketch plane. So the sketch plane would be my hand. Now, if you change the angle of it, you'll notice you're not actually getting the full length of what you want. So the sketch projection is based on a trigonometric ratio between your cosine and your hypotenuse, if that makes sense. So just be cognizant of that. If if you had like a diagonal sort of line or a diagonal sketch, and your new sketch frame is not parallel to that, you're not going to take the full length and project it onto your sketch. You're going to have a portion of it, one component of your sketch, if that makes sense. So that's one feature that's pretty useful. So I'm just going to keep this, and I'm going to make that extrusion that we made before visible. And we're going to extrude the outer edge now. So it's automatically selected that, but if it hasn't, you go into selected contours and you click on this box, and it'll allow you to select something. So let's say this is going to be like 2 centimeters. Now, we're not only constrained to extruding in one direction, we can also extrude in another direction too. So say if we do direction 2 and extrude by 2 centimeters, you'll notice our sketch plane is actually right here. It's sort of sandwiched in between these two different components. And what we can also do is sort of taper either of the sides here. So there's this draft feature. And essentially, you'll see this is not parallel to that initial line before because it's sort of tapered in. And if I change the draft angle, it tapers in more and more until it can't really do it anymore. So if we press OK, you'll notice we sort of have this like canoe type structure here. So again, SolidWorks makes it pretty simple to actually work around a lot of these tools. Now, I'm not going to get into the specifics of a lot of these different tools. I'm going to show you the basics, but the next important tool would probably be the revolved boss / base feature. So say if we essentially suppress everything that we created before. So you can either deleting, you get rid of it permanently, but if you want to not deal with it for the current type of object you're creating, and you just want to temporarily put it away, you use the suppress tool. So you see everything's gone now. And if I create a new sketch and select the top plane once more and press the Y axis to align our camera with, say if I create a circle, right? And we'll make this extremely basic. We'll create a semicircle like we did before, and we're just going to trim the rest of it. And I'm going to exit this sketch. You'll notice I did this intentionally because this is an axis upon which we can actually revolve. And you'll see what I'm describing right now. So if I press revolve boss / base, and for our contours, it's automatically selected what we wanted. But let's say this is like 180 degrees and we want to select this contour. Essentially what it's doing is it's taking this shape that we created and it's rotating it around this axis here. So you see this sort of major line that we created. And essentially it rotates like so. And you can create circular objects like this. And if we do that, boom, easy sphere. Not a lot of effort that you need to put into that. So that's one way of doing it. You could also do the opposite of all these different tools. So say if I get rid of this sketch and unsuppress what we had before. So I'm going to delete this. And I'm going to unsuppress all of this. Say we wanted to create like a hole right in the middle of this. What I can do is I can press the sketch button, create a new sketch, or we don't even need that. Let's go back to our old sketch. Let's go on to this sketch because it's already on the same plane that we wanted to deal with before. And let's say we want to create like a circular hole right in the middle. You know, I'm just going to give it a quick dimension. Let's say 8 inches for its diameter, or 8 centimeters for its diameter. What you can do now is exit the sketch. I'm going to make it visible. And we have all the contours that we used before available to us. So I'm going to hide the contours on the bottom. So right-clicking that. And if I press extruded cut now, essentially what you'll be able to do is actually cut into this object. So if you say drag that all the way down, we created a hole. Now there's different aspects of that I want to cover as well that I think would be beneficial. For instance, if you click on here, the through all feature is pretty important. It's used quite a lot in a lot of mechanical designs, especially for like shaft hole basis designs. So if you press through all, essentially any type of physical geometry in front of this sketch along this axis will be eliminated. So if I press that, it's equivalent to deleting everything in the path of that circle. And that's pretty useful. You don't have to take any measurements or do any arbitrary extrusions. That's one way of doing it. And then you'll notice it's essentially the exact same as extrusion. You can do the exact same things as before, you know, go up to a specific surface, go up to a specific body. It's really up to you. I'd advise playing around with that stuff for the most part, but you can also change the side that you cut. But in this case, since we don't have anything above the circle, it's gonna create an error because there's no solid bodies to actually cut. So that's another feature. And I'd say finally, probably a more important feature would be the Lofted Boss / Swept Boss features. So if we have our sketch from before and essentially press the Lofted Boss / base tool, we have profiles that we can select. So if I select this profile here, so one connected chain, but we want to do a region. So we click that and press OK. And then for our second profile, we want the underbelly of this sort of boat structure. So, oh, my apologies. I should have clicked at sketch. 1 second. I gotta make this visible. There we go. And okay. So the Swept Boss and the Lofted Boss features are distinct in the sense that one of them allows you to take 2 different sketch profiles and essentially create an extrusion between the 2. So that's one way of doing it. And in this case, I'm on the Swept profile. Essentially, you create one profile and it follows a curve. So say if I click on this profile here and we want to go along this axis here, it'll essentially do that. So what it's doing is it's taking this sketch profile that we had before, and it's using an existing line, and it's essentially extruding this profile along that line until it ends. So if we press OK, you'll notice it created a completely solid object. So that's for the sweep. Essentially, the key thing to remember is you need one sketch and just one curve in order to do that. For the loft, it's a little bit different, and it's a little bit more complex in when it works. So you need two profiles to do this. So if I wanted to do this again, and I'm sorry for messing it up the first time. So we do that, and we select this second contour here. So I'm gonna hide this structure. So I actually have to exit that and hide that. And there we go. The sketch profile is all we wanted. So say if we do a Lofted Boss, click this guy and press within that region. And then we do this guy and press within that region. Oh, my apologies. I did not mean to do that. I pressed the wrong button. Although it automatically selected that for us, but you'll notice it didn't do the right region. It actually went and did the middle. So you want to flip those two. But essentially, if you have a guide curve of some sort, so say if we use this curve, it sort of directs where it should go. So this feature is extremely important if you have like, two different sketches and you want to fill the gap between the two. But it's not necessarily compatible for what we want to do here. And finally, I'd say this is more minor, but fillets are something we use quite often. So if you press the fillet feature, you'll notice essentially it rounds off all of your edges. So if we go all around and click all of these edges and press OK, it'll give us a 1 centimeter radius fillet on each end. So this is more for, design for manufacture principles, and those are more mechanical related, but we'll touch on those really lightly in the next videos. And the opposite of that would be a chamfer. So essentially, instead of having rounded edges, you can essentially get rid of your fillets. So if I delete those, and if I round them out, and go all around, but you can actually just click the face and it'll do the same thing. So if I get rid of this, you'll notice it took every type of contour around there and it created a slant, or a diagonal type of face here. So it's not necessarily round. And again, I don't think a lot of you are going to be using CNC milling machines, but essentially, the tools that we use have limitations, and these types of tools like fillets and chamfers allow us to work around those limitations and ensure that we're not creating something that's impossible for a drill bit to actually do. But yeah, that's essentially it for this tutorial. Those are the tools you'll need for the most part. But if anything comes up, just let me know. I just am wondering, are there any questions at the moment? I sort of ripped through that a little bit quickly, but my intention is just to see if anyone has any feedback for the end. Oh, yeah, we have something in the chat. Yeah, no worries at all. It's my pleasure. So yeah, this was a very basic CAD tutorial here. For the next video, what we're going to be doing is we're actually going to be creating the halo upon which lies on your head. So that's going to be the basis of which we create our screen for our mask. And then in the third tutorial, we'll be creating the mask itself. And then what we're going to do is we're going to attach that onto the halo, or the headband that goes around your head. So that's essentially it. Let's see, where can we access the recording of this tutorial? So we're actually going to be uploading it to McGill aCADemy's YouTube, but what we can do is distribute it to McGill BioDesign as well. And if you guys want, if it's fine with you guys, just distribute it amongst your platforms as well. But all of our tutorials as well, which go into further depth, are on our YouTube channel. So I can add a link to that. I'll stop sharing. One moment. Okay, so let's see. Are there any other questions at the moment?